The RL-10 rocket engine, power plant for the Centaur and Saturn, is the result of years of research and development. The highest performance engine built in the free world using safe, reliable, and dependable hydrogen. To maintain the high degree of reliability of the RL-10, vital parts are assembled under stringent laboratory conditions. Following a typical engine through its paces, the thrust chamber tubes are installed. After the assembly is placed over a mandrel, the manifolds and bands can be attached. Silver wire is laid in for furnace brazing. Placed in a retort, the chamber is ready for the furnace. Once brazed, the chamber undergoes testing to assure trouble-free operation. Liquid nitrogen is forced through the chamber to perform thermal shock tests. Pressurized with gaseous nitrogen, the chamber is checked for leaks. The inspected subassembly is dried out in a special oven. Final chamber assembly is completed with the installation of the injector. A special jig is lowered to accurately align the injector. Then the chamber goes for final machining prior to assembly of the complete engine. On the assembly floor, all parts come together. Fuel lines, valves, turbo pumps are brought from clean rooms, assembled, installed, and inspected. Multiple inspections of each component and subassembly assures maximum reliability. Ready for action, the completed engine must undergo the test of firing. The RL-10 is made ready for transport to the test site. The operating principle of the RL-10 can best be shown by this simple diagram. Hydrogen at 37 degrees Rankine, minus 423 degrees Fahrenheit, enters through the inlet shutoff valve, passes through the first stage pump into the second stage pump, where it is discharged at 1,000 pounds per square inch. Then it passes through the cooling jacket manifold, through half of the tubes, through the turnaround manifold, back through the long tubes, to the exit manifold, and through the venturi into the turbine. At this point, the hydrogen is now gas at 850 pounds per square inch and 350 degrees Rankine, minus 110 degrees Fahrenheit, and provides the power to drive the hydrogen and oxygen pumps. It then goes through the main shutoff valve into the injector and to the combustion chamber. Drawn in through the single-stage oxygen pump, oxygen flows through the inlet valve directly through the mixture ratio control valve into the injector to combine with the hydrogen in the chamber. The engine itself is as simple as the diagram. To demonstrate, hydrogen enters at this point, flows through the first stage pump, into the second stage pump, passes through the cooling jacket manifold, down through half the tubes, to the turnaround manifold, up the long tubes, collected at the exit manifold, through the venturi into the turbine, There it provides the power to drive the hydrogen and oxygen pumps. Then around the large line, through the main fuel shutoff valve, into the injector, and then to the combustion chamber. On the oxygen side, oxygen flows through the inlet valve through a single-stage pump, directly through the mixture ratio control valve into the injector. Arriving at one of the vertical test stands, the RL-10 is installed and made ready for test firing.
19, 18,
Space firing conditions will be simulated.
15, 14, 15, 12,
A steam injector system lowers the pressure to the near vacuum of space.
7, 6,
Cameras on. Good timing
4,
on.
3, 2,
Heat is good. Head shell is good.
0.
On completion of this test firing, the engine will be returned to the manufacturing area for complete disassembly, inspection, and reassembly. Years of experience, research, and development have gone into the design and manufacture of the Pratt & Whitney aircraft RL-10 rocket engine.
Pressure 320. Temperature on your
There you go.
diffuser is
Must have
175.
shortened that micro switch.
The RL-10 has also undergone space condition testing at the NASA Lewis Research Center, where special viewing ports permit continual visual check of space condition firing. Pratt & Whitney Aircraft's around-the-clock development program is helping accelerate the United States space effort.